Okay, Assalamualaikum, very good morning. Testing, testing mic, testing, 1, 2, 3. Can everybody hear me? Testing, boleh dengar tak? Alright, okay, boleh dengar Now ada reply. Okay, alright, thank you. So you can see me, okay. So, Assalamualaikum and very good morning. Okay, can you see the screen right now? Boleh nampak screen? Boleh? Yes, alright. So, yeah, Assalamualaikum and very good morning to all. So for this morning is that we are going to continue for chapter 7, and so we have 2 more chapters, chapter 7 and chapter 8. So if you see in the teaching plan, we have chapter 8 and 10, but I think that one of the chapter is that I'm going to explain about chapter 8 is on the basic control system. So for today is that I'm going to cover for chapter 7, which is the final part of actuation system, which is the electrical actuation system, right? So this one I have uploaded in Learn the slide, and the link for the YouTube also I have uploaded the slide, so you can just after this class you can go to the slide. If you want to see the video that I shared, then just click on the link, right? So that will be the self-study, right? So let's just go through. So for this chapter 7, we'll actually cover for LO2 and LO3. So LO2 will be explained the working principle of the electrical actuation system, and LO3 will be the analyze the selection integration of the system. Means that to integrate, select the what type of motor and then to apply it to the system. So as what you have gone through your assignment. So we have seen that your assignment is actually comprised of all the chapters in this subject, which is introduction. So we have covered for the measurement system, okay, we have the functioning, then you have the sensors, okay. Then next was that we learned about the actuation system, actuation block. So on the actuation block, as you know, we have 4 main types of actuation system. The first one is depending on harmonic. The second one is mechanism or mechanical actuator, and the third one is the third one will be electrical actuator. So actually for pneumatic and hydraulics, I combine those. So total up it would be 4 types of actuator. Okay, because pneumatic and hydraulic are used for different application. Okay. So and in the last part of this subject is where you actually combine all of the components, the measurement system, the actuation system. Then if the system requires controller, then how do you actually connect with the open loop to make it from an open loop to a closed loop block diagram. So that is where your assignment is where you apply what you have learned for all from chapter 1 until chapter 8 into the assignment, and this will actually be tested on all the students during final exam. Okay, so make sure that for the assignment, do focus on the assignment. Focus really well on the assignment task. Okay, don't just simply take it for
Hello,
granted.
Doctor. Not clear, Doctor.
Why is not clear?
Your voice, Doctor, not clear.
How about the other student? How about the other student?
Not clear as well, Doctor.
Oh, yeah. You guys, I dah bercakap banyak, lepas tu not clear. Okay, next time please inform me from the start.
Ingatkan saya seorang.
No, don't do that. Okay, I nak explain panjang lebar. Okay, please make sure that you from the start. Right now here, just now kan I test the mic. Okay, when I ask testing the mic means that is it clear? Now is it clear? Is it clear right now? Hello?
Okey sikit.
Much better, Doctor.
Okay, make sure that okay, not clear tu ada orang type kan dalam chat kan. I sebenarnya when I start giving lecture kan, I'm not going to look at the chat here. Chat tu is actually closed because it will actually disrupt so anything if it's not clear, cannot see, please voice out on your mic. Okay, think this one you guys bukan kids anymore. Okay, please voice up. Okay, because if not, wasting time lah dia cakap tadi kan. Okay, tak tahulah boleh repeat it or not sebab tak dah lupa dah apa dia cakap tadi So now, is it clear? Okay, testing now, clear? Yes tu clear ke tak? Yes tu dia sama ada dengar. Okay, dengar tapi tak clear. So now, is it clear? From 1 to 5, which one?
4.
4. Okay, the rest, the other student?
4.
4. So, boleh dengar sekarang ni?
Boleh, Doktor.
Boleh, okay. Means I kena jerit sikit lah dalam bilik ni. Okay. Right. So, clear Alright. Well, clear, then I will continue. Kalau I ingat lah apa yang I explain tadi. So, I was talking about assignment Okay. So, what actually we have learned in this subject from chapter 1 until up to chapter 8 is that we have learned to use all the knowledge to apply it into your assignment. Okay, so and this chapter 7 will be the last chapter. This chapter 7 will be the second last chapter. So we have one more chapter, chapter 8. So make sure that the assignment don't take it for granted. Means that do last minute, because what I see is that I can actually see who's doing last minute or who's actually already almost finished doing the assignment, because in the turning in, I have seen that some students have uploaded, but not much student uploaded the assignment yet. Okay, so we have one more week to actually complete the assignment, so do not do last minute work. At least spend like 1 hour each for 1 hour per day for this assignment. Okay, but if I do, I would focus it on the weekend to finish it up. Last week, I have given you two hours. Okay, 2 hours class on Thursday and Friday, 1 hour class according to their schedule to actually focus on your assignment. So you actually should have completed 3 hours to focus on your assignment. The reason why is that in the final exam, you're going to have a similar case study. Okay? And the question is not going to be one question. Okay, like you guys. Okay? So, hello, ini saya di kelas Tinggal saya nak kena check dulu kalender. 12. 12 hari apa? 12 hari apa? Kejap tengah kelas kejap. Alright, sorry about that. Admin call lah. Ada meeting, so nak kena tukar timing. Okay, so back again to the assignment. So for the assignment is that make sure that we do not do last minute work. Okay, because it will actually impact to your final exam. Okay, and later on you will actually regret that you didn't focus doing your assignment. And for your information, for the final exam, the question will be similar, shuffle. Okay, case study will not be the same for each student. So do not expect that you can actually copy from a friend. In the end, you think that it's going to be an easy job lah to answer this final. So do not assume that. So make sure that when you go for final exam, you come in prepared. Okay, prepared means that to actually study and do assignment right now. So this is tips on how to score for the subject. Okay, so for this chapter 7, okay, so I'm going to go directly to chapter 7. Later on, I'm going to explain on what assignment is the status of your assignment. Right. So for is that okay, you are going to learn about explain the different electrical actuation system. Okay, explain the basic operation of the electrical system and application of the electrical system. Electrical actuation system means that after you select it, you identify what type of motor you want to apply. DC motor, AC motor, step motor, alright? So or servo motor. So after that, how are you going to apply it to a system? Are you going to connect it to a mechanism? So what you have in that doing for your assignment. So you're going to connect it. Maybe you want to connect the shaft and the shaft of the motor to connect it to a mechanism, to a gearing system, to a ball screw system. So these are the things that where you need to know or understand each of the components in this subject. So mechanism, how to convert from one to linear. Okay, what type of mechanism you need when you want to, like when you have a motor is going to rotate in motion. So if you want to have a linear motion, so what type of mechanism that is available? So this is where your assignment will be really helpful for you to understand or to answer the final exam. Okay? Right, so so this one is just so for the review. So we are still over here on the actuator system, and we are still doing this part on the actuator. So this one I have covered. So what are actuators? So it's actually to transform the output of microcontroller into a function. So we are going to convert it from a signal, give a signal to the actuator, and the actuator will give motion or force. Right. So this one I have covered also. So a little bit on revision on what is actuator. So actuator is what is actually to produce mechanical movement or motion in the system, and the input is either electrical signal. Okay, for example, for electrical actuator. So the input is an electrical signal. It can be either current or voltage. So for pneumatic actuator, so the input will be pressure, and for the hydraulic will be the input will be friction. So and for the output is that when you have an actuator, the input is a signal and the output will be a motion, force, or pressure. So that is where you have the output linkage of the open loop. So if you were to actually draw, okay, this input output, so you have a block diagram over here. For example, this is actuator. I'm going to draw on the actuator. So actuator, okay, and we have the input here, okay, input, and we have the output. Okay. So this is where we have, this is what we call as the block diagram. Okay. And then the electrical signal, if it's a low powered or if it's high powered. Okay, so you might want to determine if it's low powered or high powered. So in the case of low powered, you add amplifier. Okay? Okay? So anyway, for the working range when we talk about working range, this one is the working range of the actuator. Okay? Working range of the actuator itself. So it can be means that the displacement, when we talk about this one, when we talk about from few microns to few meters, so it means that in micrometer until millimeter. Example. So if we talk about the linear motion, so it will be in micrometer to meter. Or if you want to talk about rotary motion, that is going to be in microdegree, okay? Until degree lah. So microdegree in for example 1 milli. Example, if you have a very good sensor, okay, then you can actually control the output in that a few micrometer, few micron. So where do you actually make this very small displacement? Okay, so back in 2016, back in 2016 to 17, I was working in a clinic on the back end, on the front of line, on the back end, and the department that was attached was on the one-word process. So one-word process is something that is similar to soldering of chip, okay, chip wire to the chips. So it's very small. Imagine that chip is actually used for your handphone. Okay, for your handphone, the chip is very small, or the chip is used in your car, for example, for the airbag system and so on. So this chip is very small, and how they actually solder the chips is by actually using the Y1 machine. Okay, if you remember in the beginning of week one or week two, which is under chapter 1, you actually I have given you assignment on the semiconductor process on the front of the line. Okay, if you remember, there are front end and back end. For example, in Infinity, you have the front end in Kedah, and you have the back end in Melaka. So the one back end is the process of assembly. The one in the front end in Kedah is actually the process of doing of producing the wafer. Okay, the wafer. So then the wafer will be taken to the Melaka back end. The back end is where they will cut the wafer, which is on the wafer there's already the chip. Okay, they cut the wafer and process until it's you are going to deliver it to the customer. So one of the process on the back end is Y1 process, where the wire is actually bonded to the chip. So how they do it is that they are using very fine actuator and very small, very precise sensor. So because it's going to move in micro displacement, in micrometer displacement, right? So maybe right now you can imagine where is the application, but later on when you start working, you find out that there are lots of applications where they are using very small micron up until meters. Right, so far boleh dengar? So far okay?
Okay, Doktor. Okay.
Okay, alright. So, right, thank you for the feedback. So next we are going to continue for the electrical actuator. So what we have done before was on the pneumatic actuator, hydraulic, and then of course mechanism. But mechanism I didn't write it out here because mechanism is actually applied to all of these actuators, pneumatic, hydraulic, and electrical actuator. And for today is that we're going to look at the electrical actuator. And under electrical actuator, since you are background, you are actually at the FKD, electrical engineering. So you should know more about this electrical actuator. So for today is that you're going to learn about first one is DC motor, types of, this one we call as the DC motor type. Okay? And then we have the DC motor. So therefore for DC motor we have three types. We have the DC motor, we have this normal DC motor, and we have the servo motor, and then we have the starter. So this one is type starter motor. And then next we're going to look at the AC. So what I'm going to focus more will be on the DC motor, and of course we know also what are the difference between the DC and the DC. Right? And remember, for all of this, we're going to apply mechanism. Okay, mechanism, what type of mechanism that we have? Like, for example, reduce. We have what else? We have clearing. Okay, so just go back to the previous chapter, and then we can actually list out what are the types of mechanism used. So for the element of particle system used in control, okay, so normally we would call it as an actuator. Okay, anything that can actually make a movement, cause or torque, okay, using an electrical signal, okay, we call it as an actuator. So the first one that we are going to learn is about switching devices. Okay, switching devices. So which is this is the control signal switches on and off of some of the electrical devices. The common one you can see is relay. Okay, and then you have the solid state switches. For example, direct resistor and transistor. So example of relay that you can see is mostly, for example, in our house we have the circuit breaker that just a relay. And then the second one is the solenoid type devices. So these solenoid type devices currently normally it's being used to actuate hydraulic and electric fluid. Okay, so we will see what's the difference between these two. And next one is drive system. So when we talk about drive system, it's mostly on the DC motor or AC motor. DC motor and AC motor. Right? So let's go to the next slide. So this one, FYI, in my slide that I have uploaded, I have actually organized it slide, but it's not going to deviate much from with what I'm showing you today. Okay, so before I go to it on the starting with the DC motor, I'm going to explain first about the rules of electrical rules. Just a recap, because you have learned this actually in your physics during your SPM, like in the school, and during matriculasi, I think most of you also learn it. So we are going to go through a recap. Okay. So the first one is for the electrical hand rule is the right hand rule. Okay. Right hand rule. So what you're going to learn is that how to determine the direction of the electromagnetic field when you have a current here. Yeah? So we have a wire going to the current. So what is the direction of the field? So let's look at this. Okay? Let's look at this. Okay? So if you have a right hand rule over here, you can see that you have the positive and minus. So imagine that you have power supply over here. Power supply, so it's connected to the positive. Then this one will be connected to the negative. That's a bit crazy right now. But anyway, you get the idea. This one is connected to the power supply. Okay, so you have the flow is going through like this. Okay. Okay. So imagine that I have this one. You can look at me right now. Okay. You have the current flowing upward. Okay. So you're going to use the right hand rule. Your right hand. Your right hand. So take the right hand. If you have a pen right now in front of you, take that pen. Okay. So take the pen and using your right hand rule, just wrap it around your hand. Wrap it around your pen. Okay. So when you wrap it, means that the direction, your thumb will actually indicate the direction of the current. And the other finger, the fourth finger is the direction of the field. So therefore, if you see here, okay, if you see over here, okay, so you have the finger over here, and then your finger is in the anti-clockwise, okay, anti-clockwise, right? So what you see over here is the B. The B is in the direction of magnetic field. Okay, this one, the blue line is in the direction of the magnetic field, and you have the current moving upward. So that is how you determine the direction of the magnetic field. Okay, this one is the right hand rule. Okay, let's go to the second one. Okay, we have the Fleming left hand rule. The Fleming right hand rule, as per mentioned, you're going to use your left hand instead of your right hand. Left hand. And you're going to use 3 fingers here. And make sure your fingers are 90 degrees to each other. And so, for example, this one is 3 and this one is 3. So, if you see in this slide, you have your palm is the motion. Okay, so Fleming right hand rule is actually to explain about the motor rule. Motor rule. The motor rule is that when you have a current, okay, you want to know what is the direction of the motion. You have current, you have a field, you have a field, inside the field, and then you want to know what are the motion. Motion is what? Motion of the rotor to rotate. Yeah? So, you have your current over here, okay, and then your field, and then your motion is the palm. Okay, so this one will be the left hand rule. Let me see. Maybe it's not. I will show you a video to explain this. So this one is the motor right hand rule. Okay, and if you see next, this one, Fleming right hand rule. So mean that instead of left hand, you are using the right. So right hand rule is actually to explain about the induced current. Okay, this is an example if you are using induction motor. Induction motor is one part of AC motor. Okay, so for AC motor, okay, we have induction motor. This one is in the slide, induction motor, and then you have a synchronous motor. Okay, so for AC motor is using the Fleming right hand rule. Reason why is that okay, you are going to use it to actually determine the direction of the field. Okay? So I have actually shared links of some links related to the explanation. So let's just go one of the say first. Okay, this one is the name over here. Rules. Okay, this one. This one. So rules for determining direction of magnetic field. So let's listen to this video. Okay, kalau tak dengar voice tu, inform saya.
Rules for determining the direction of the magnetic field. Observe the direction of the compass needle when the current is passing through a straight wire carrying current. Now observe the direction of the compass needle when the current is reversed. The deflection of the needle is reversed in these cases. This shows that the direction of the magnetic field around a conductor depends on the direction of the current flowing through it. Instead of using a compass needle every time, we can determine the direction of magnetic field by using rules like right-hand thumb rule and Maxwell's corkscrew rule. Right-hand thumb rule. Imagine the conductor to be held in your right hand, with the fingers curled around it. If the thumb points in the direction of the current, then the curled fingers show the direction of the magnetic field. Maxwell's corkscrew rule. Imagine a right-handed corkscrew being rotated along the wire in the direction of the current. The direction of rotation of the thumb gives the direction of the magnetic lines of force.
Okay, so that one is a simple explanation on the right hand rule, but basically we are using the right hand rule on the Maxwell screw rule. Because for if your BKG student later on the for those BKG students, they are going to take another subject which is electromagnetic theory. So it's more on the feel how they feel and so on. So let's look at this one. This one is to determine the just search lah, ada banyak yang left hand rule. I'm going to share first from left hand rule. This one.
Fleming's left-hand rule. In the earlier section, we studied about a motor. But how can we determine in which direction will this motor rotate? If direction of magnetic field and current is given. We will discuss one rule, the Fleming's left-hand rule, on the basis of which we can find the direction of force, the rotating direction of armature coil, for the given direction of magnetic field and current. According to this rule, if you arrange your left hand in such a way that your thumb, first finger, and second finger all point at right angles to one another, and if your first finger is pointing in the direction of the magnetic field, second finger is pointing towards the direction of current, then the thumb will give you the direction of the force. Let us check out the left-hand rule once more against the animation. Have you understood the rule? No? Okay. Now let's understand this by taking a simple circuit. Now arrange your left hand with thumb, first finger, and second finger all pointing at right angles to one another. Now point your first finger in the direction of the magnetic field. Point your second finger in the direction of current. According to Fleming's left-hand rule, the thumb will give the direction of force. In this case, the conductor will experience a force in upward direction, or it will move up. Now, can you guess in which direction the conductor will experience a force if we reverse the direction of current?
Okay, so did you get the idea? Right? Did you get the idea of it?
Yes.
Yes, very simple. So I think I don't need to explain it. I can explain it, but I think you can just go through YouTube and find what you get for the explanation. Okay, so that is one thing. So you have three types of rules. Right hand rule, and left hand rule, and right hand rule. So just go through if you are not sure what's the difference between left hand and right hand. Then go find this is will be a self-study. Okay, so I just guide you. Okay, what type of rule that you need to do. Next is how about solenoid? So solenoid is that something. For example, you have a solenoid means that coil. Solenoid is actually a coil. So imagine that in this slide you have only one wire. You have one wire like this, only one wire. But for solenoid is that okay, you have the connection like this, and then we're going to have the solenoid like this. Okay, so of course it's going to move in that direction. So this is actually the solenoid now in the drawing. Right? So imagine that you have this positive supply and negative. So the current is moving in, and here is the current is moving out. Okay, similarly, using the right hand rule. So right hand rule, use the right hand rule. Because for the right hand rule, as mentioned, is that for the right hand rule is that to determine when you have a current, okay, you want to determine the motion, or you want to determine the force. The motion, of course, is the same thing. So motion means it's going upward or downward, or force is moving upward or downward. Okay, so if you were to have this solenoid, so what are the directions? So this is very simple. Okay, so imagine that you have a solenoid. Okay, solenoid. So you're going to determine the motion using first is the direction of the current. Okay. So if I were to take right now the current is moving upward like this. Okay. So upward like this. So you just put this one is the motion of current. Now put this like this, then current is moving upward. So you can see that the field is moving in the direction of counterclockwise. So that's why if you see here, counterclockwise, if I were to actually put this inside the location here, okay, here you see that this one, you have the current here, and then you have the loop of your finger over here, the other finger. So means that the magnetic field will be in this direction, right? So this is what it means. So the direction of the magnetic field is from south to north, north pole to south pole, south pole to north pole. So this is where you will get the magnetic field. Okay? So where do you actually use the solenoid? So solenoid is where you're going to use it in a relay. So in a relay, you will have an iron core in the middle here, and the iron core is actually wrapped with the solenoid. That means that the wire, which is solenoid. So it's going to be connected to solenoid, and then this one will be connected to pole source. And if you see here is that this this circuit is actually not a closed circuit, and this one is the one that you're going to connect to the load. It means that if you see here, the connection to the load is open right now. So it means that if the solenoid is not energized, it just means that you didn't give any current to the solenoid, then there will be no magnetic field. Okay? So let's just go through the relay right now. So for example, we have the negative here, in fact we have the positive current and negative current. So the current is moving in which direction? Moving in this direction. So let's just look at it. So moving in that direction. Okay? That direction. So you have the magnetic field moving downward. So magnetic field, if you have current here, magnetic field is going downward. Okay, means that if you apply current, okay, then this contact will actually pull this the shaft, the switch here. So the switch from normally open, okay, normally open will become normally closed. Okay, so when it's normally closed, then you have the connection. So this one you actually can, yeah. So this one is actually a hinges. If you remember, in mechanism, you have learned about hinges, can hinges. What was the type of hinges that you learned? For example, spring, spring. So this is type of spring. Okay. Okay, let's go to the relay. So how does the relay work? So I think you can just click on this and look at the animation. But I'm going to explain in terms of theory. So what is a relay? So a relay is electrical operated switch and used as electromagnetic to operate switching mechanism. So I have explained it just now. case. So means that when there's current over here, there will be a magnetic field, B, okay, and then so therefore these hinges will actually contact here. So means that there will be current to the load, right? So this shows the real relay. So you can see that there's a solenoid over here and movable armature. Movable armature is actually this thing lah. Movable armature is going to move according to the solenoid. And there are some relay that can see here. I think most of you can actually buy this type of relay and you can look at operation. So how does the basic operation? Or basic design. So a simple electromagnetic relay consists of a coil of wire wrapped around a soft iron core. So you have the iron core over here, okay, and then you have the coil wrapped around it. And then you have an iron yoke which provides low reluctant path for magnetic flux. Okay, you have the yoke over here, a movable iron armature which is here, and one set of contacts. So this one is the contact, the set of contacts over here. So explanation is that the armature is hinged to the yoke and regularly linked to one or more secondary moving contacts. So sometimes in a relay you have a few moving contacts, but for this case is that you have only one contact, which is normally open, and it is held in a place by a spring. So this one part just now I explained is a spring, so that when the relay is de-energized, there is an air gap in the magnetic field. So what it means that when you energize is that this armature will actually close, which is from open, normally open, become normally closed. Then when it de-energizes means that you cut off the power supply, then it will open. Okay, because when there's no magnetic field, then there is no force over here. Okay? So that is the concept of the relay. Okay, so based on that, then we will go through each component, the main component. So we are going to first look at the electrical motor. We have three types, which is the DC motor, DC servo motor, AC motor, and servo motor. And then we are going to look at a drive system. We have open loop and closed loop, and then we are going to look at the motion control, and control. Okay, so let's look at the first one, which is the electrical motors. So electrical motor is to actuate something. So example in a robot is to actuate wheels, its leg, its arm, fingers, sensor pivot, and electric system. Example lah in a robot. If you look at example Iron Man, there's an actuator over there. That's why you can actually lift up heavy things. So that's actuator. So what actually actuates? So most of the time we're using electrical motor for that. Because if you're using hydraulic and pneumatic, then you need to have a compressor. You need to compress air and so on. So of course for robotic, if you need to have a compressor, then it's going to be very small compressor, and small compressor will be very expensive. Right? So normally people use electrical motor for this type of for robotics. And there are four main types of electrical motor. So let's look at the first one, which is on these three electrical motor. So anyone knows what are this one? First, second, and third one. Any idea? Guys, I need this one. Any ideas? What is the first one? The hint is, the difference is that look at the wiring. So you see that there's for this one is that you have only 2 wires. This one you have 3 wires, and this one you have 3 wires. 4 wires. Okay, we have 4 wires. There's green, blue, red, and black. Okay, so any idea? Anyone?
DC motor.
First one
Which
is
one?
motor.
DC
First
motor.
one is DC motor.
Alright, second one?
Servo motor.
Servo motor. Third one?
Stepper.
Stepper motor. I believe those who can answer is actually they go through the slide. I believe that. Okay, so there is a tip. if you want to answer, then you need to go to the slide. So correct, eh? So the first one is a DC motor, second one is a servo motor, and third one is a step motor. And how you can actually differentiate each of this is by looking at the wires connected to the motor. So for the DC motor is that you have two wires. You have the power, the positive and ground, two wires. For servo motor, you have three wires. You have this the positive power, this power, positive minus ground, and then you have the control signal. So are the people. For the stepper motor is that normally you have it's going to have a three phase. That's why you can see that there's a three phase. You have the green wire, blue wire, and red wire. And the black wire is actually the ground. So total out you have four wires. So that is how you determine which type of motor it is, based on first impression. You can do directly. So on how to actually look at how DC motors, servo motors, stepper motor works, you can just click on the link. I'm going to explain it. So for the DC motor is that there are two wires. You have the power and ground, and it's going to be a continuous rotation. It means that if you apply current, if the current or voltage, then it's going to rotate without stopping until you cut off the power. That's all. So that is what DC motor is about. Okay. So the DC motor, the controller, you can actually control the speed of DC motor using valve modulation. So this one, remember you have to learn it in the measurement system, signal conditioning on valve modulation. So how you actually increase the speed is by reducing the ratio. Okay, and then so the percentage of time spent cycling is that the on-off ratio will determine the speed. Okay, so it means that if you put it 50%, then the speed will be half of the maximum speed of the motor. If you put the ratio 70%, okay, the ratio is 70%, then you are going ratio of the PWM, then you're going to have as the speed. So what does it mean? Remember that last time when you have learned about the force with potential and something like this. Okay, assuming that this is a ratio of 50%. What does it mean by 50%? Okay, so 50% means that this ratio is one cycle. Okay, correct, one cycle. This is one cycle. One cycle. Okay, so 50% means that this and this is 50% same ratio. Okay, so if you want to actually increase the ratio, you can actually change the PWM, change it. Okay, make it smaller ratio, but we have still the same cycle. Okay, smaller ratio. Okay, so what is the effect? So this one you can actually go through, test it out. If you have Arduino, you have a motor, then you can just simply test it out, okay, by switching the input to the DC motor. Okay, so application, where is the application? Application, you can use it in a continuous motor lah. For example, if you are designing autonomous car, so you want it to move forward. Okay, move forward, then you can use this motor. Move backward, then you can use this motor. Right, or fan. You have a fan at home, you click on the switch, which level 1, 2, 3. So 1 means that there is different PWM value inside actually. Okay? So how does electrical motor work? So electrical motor actually convert electrical power into electrical power. So you give a signal that is going to convert electrical power. Mechanical means that the motion is going to rotate. Okay, so basic concept of electrical motor is that you have stator and rotor. Okay? And where is the stator? What is a rotor? So this is what we call as the stator. Stator. Okay, stator. Stator means fixed. Always remember, when you have a stator, it's something which is fixed. And rotor is something that is moving. Okay, and rotor normally is connected to a shaft. Okay, so imagine that you have a stator, you have the north pole and south pole over here. So north pole and south pole. So if north pole and south pole, what is the direction of the magnetic field? The magnetic field is from which to which? From north to south ke ataupun south to north? Guys, magnetic field. Guys, magnetic field direction from which to which? From north to south or south to
N to S.
N to S. It's N to S. Confirm, eh? Confirm?
Yeah.
Confirm. North to south, eh? Okay. So correct. North from north pole to south pole, eh? So therefore, if you see here, always remember for DC motor, you have that. Now you have magnets inside your motor. Okay. So make sure that and what you want to rotate is actually the rotor. You want to rotate the rotor. Okay. So look at this example. Okay. Habis apa yang on? Boleh off kan mic. Ada macam ni. So we have the north pole to south pole over here. So this is D. Sorry, kejap. Okay, so right now, if you see here, you have the north pole to south pole, so you have the direction. So remember, this one is using the left hand rules. Okay, so you have the positive power supply and negative, so it's going to move in this direction, means that I will be in this direction. So for a DC motor, normally what you want to determine is that the motion, the direction of the rotor over here. This is the rotor. Okay, the coil there is the rotor. So you want to determine the direction of the motor. So you want to look at, is it going to move in counterclockwise or in clockwise motion. So let's just look at this one. So you have current over here, field motion. So current is going to go into this area. So current is going to go here. And then you have the magnetic field is going to the left here. Okay, just try to do it at home. So that here. And what you see is that you have the motion moving upward, motion of force going upward. So therefore, because of that, means that you have the force moving upward. This force. Okay, in for this point only. Okay, but for this direction, okay, you have I in the vice versa. Okay, I in this direction, and then you have the magnetic field still in the same direction. So you have the force going downward. So here is that the force going downward. Therefore, if you have this motion continuously when you apply a supply, what happens is that this rotor, this shaft will actually rotate in clockwise position. So this is how the principle of electrical motor. Okay. If you have power, then the motor will actually run. Okay, when you cut it off, then the motor will stop. Okay. So normally this rotor will be connected to a shaft and it will be connected to a bearing. So this shaft will actually be linked to a gear, to the screw or spindle. Okay. So I just want to share with you an example. Okay, you see this one, this example, if you see this example, this is one example of a actuator, electromagnetic actuator that was designed in our lab, research lab, student design. So if you see here, okay, we have this one is actually the actuator. We have to see that there's a cord inside there, and then this inside there, the rotor is connected to a shaft. This one is the shaft. This one is the shaft. Okay? This red line is the shaft, and this shaft is connected to a bearing over here. So bearing. So that's why we can actually rotate the rotor inside. And at the end of here, you can see that this one is an encoder. So encoder or sensor, so to actually detect what position is moving. Okay, so this is one example. Right. So for the DC motor is that you have two types, brush DC motor and brushless DC motor. So for the brush DC motor is that normally you have the commutator as well as switching device. Okay. So the advantage is that it results in arching one brushes and maintenance. So what is actually the commutator? So commutator, if you see here, is that this one, this one is commutator. So it's going to actually always brush with the rotor over there. So it's going to actually wear off. So for the brushless DC motor is that it's going to use a solid state switching. So advantage is that it's going to reduce inertia of the rotor assembly and you have higher speed actuation. With that, because it's brushless, it's not going to have any friction, and therefore brushless DC motor is better for application now. But of course, brushless DC motor will be much more expensive than the brushless DC motor. Okay, so this one example, so I think we can just go through, it's the same explanation. So we have the data, this is the brush, this one is the brush DC motor, and then this is the brushless DC motor, and then you see here there's no connection after this data. Okay. And next we go to the DC motor, DC motor. So for the DC motor, generally, if you see there, is consist of four things. We have the first one is DC motor. Means that DC motor, in this is a motor, we have a DC motor also manual. Okay, but other than that, you have a gearing system also included inside. Okay, you have a control circuit, and then you have a sensor inside. So basically, it's actually two in one, okay, or three in one. Means that you have a motor actuator, you have the mechanism, and then you have the sensor inside that. So it means that if you are using DC motor, you do not need to actually implement any other sensor inside. Okay, but for DC motor just now, there's no sensor, so you need to buy an encoder to actually attach it to the shaft so that you can read the motion, the rotation. So inside here, if you see this DC motor, you have the DC motor. Okay, it's connected to a shaft, and if you see here, this is what type of gearing system. This type is a worm gear type. So you see that it's like this kind. This is called a worm gear, and it's connected to a parallel set of gearing system over here. So you have a gearing system, and the end of the gearing system is connected to the shaft, and the shaft is connected. This is output shaft, connected to the higher anything else according to the application. Okay, so for this is the inside part. So you have the potentiometer. Normally inside here you will have the encoder over here. You have the potentiometer, you have the signal compared with the DC motor. So you have everything inside. So for the DC motor, it's much more complicated. That's why if you see, you have actually three wires. You have the power, you have the ground, and you have the control circuit. Okay, the controller is actually to control the reference signal over here. And okay, so for position of the servo motors, it's using PWM. Okay, just that unlike DC motor, duration of the positive pulse that determine the speed of the servo shaft. Okay, so it means that for the for the DC servo motor is that you can actually control the positive pulses going to the servo motor. And application is the fast application, fast high torque application, accurate rotation than the DC motor. Because for the DC motor, because you do not have a sensor, then you can actually control the position. Of course, you can actually add on to the DC motor by adding sensor. Okay, but if you want to just buy a motor with an encoder, just directly buy a DC motor. And lastly is a stepper motor. So stepper motor is utilized motor-proof electromagnetic range around central gear to define position. So this one, if you see here, this shows a stepper motor. And for the stepper motor, if you see inside here, okay, you can see that in the rotor part, this is the rotor which is moving, and you can see that the rotor actually has two small tube. And you see that there's a stator. This is the stator 1, okay, the 1, this is stator 2, stator 2, stator 3, stator. Oh, sorry, this one ada 4 cycle and stator 4. Stator 4. So this one is actually 4 phase, not 3 phase, the 4 phase. So that's why you have the 1, 2, 3, 4. So actually for this case is that you need to have another wire for the ground wire. Okay, so maybe not sure in this photo, but total up should be 5 wires. Okay, so for the rotor, you can see that for each stator S1, we have tooth over here. Very small tooth at the stator. So because of these tools, you can actually control the stepper motor in precise position. So let's look at how it's going to do it. So advantage is that you can actually have a precise position location, easy to set up, okay? And you can actually control it in open system. It means that if you buy a stepper motor, you can actually give an input and then you can actually control the position without being close to it. Okay? But it's not going to be the best close ever lah. Okay? So but still need to if you want to actually control it very good, less small overshoot, small error, then you actually do it for the servo motor. Okay, and but for this servo motor require feedback mechanism. So normally you need to have a feedback mechanism with a sensor. Okay, and the servo motor has a positional control via the natural rotation of traction engagement. Okay, so if you want to know more, you just go to on servo motor. And for this case, servo motor is normally used for 3D printing, okay? Or similar devices that make a positioning. It's more positioning. So this one is the best to use for servo motor without adding more sensors. Okay? So if you look through here, okay, this is an example of how the driving procedure of the servo motor. Yeah, I'm showing you only for 2-phase servo motor. 2 phase are there. We have phase A and phase B over here. So phase A, we have the same current into voltage going into the current going into the actuator. And phase B here we will be having the same current. So let's look at the how it's going to drive it. Okay. So imagine that we have plus minus over here. It's going to connect to this phase A. Okay, when it's going to connect to this phase A, okay, what happens is that you have a current energizing over here, so it means that you have the magnetic field over here. And when you apply it to phase B, for example, phase B, and of course, at the same time, this phase B. Okay, what happened is that, okay, you will see that this one will overlap. It's going to move it and overlap because of the current. So this is how the servo motor actually move. Okay? Okay, so as a conclusion is that for the DC motor is that you can use it. It has high torque, okay, high speed control, but it doesn't have position control. For the servo motor is that you can actually control the position control, but the torque is low and speed is also low. Okay? And for the servo motor, that you have all the advantages. You have high torque, high speed, and position control. So the best is to use servo motor, but of course sometimes when you do your FYP or IDP project, you are constrained by the budget. Okay, therefore you sometimes use all this. You only choose servo motor or the DC servo motor. DC motor. Okay, so what are the difference between the DC motor versus AC motor? For DC motor is that you have a moving armature coil. So remember, the moving armature coil is the one that is going to move just now, the one that I explained. So the coil polarity depends on the alignment of the magnet. So DC motor will normally have a magnet. Magnet fixed this magnet. Okay, so it depends on the magnet. And the commutator automatically select the coil generating positive OB. So this one is what is DC motor. For AC motor is that it's contra to the DC motor. For AC motor, you have the fixed stator coil. Okay, you have the fixed stator. For example, this is BAC is the stator fixed, okay, and moving rotor magnet. So this moving rotor magnet means that if either you put the rotor or the magnet inside that, is going to rotate. So therefore, it's going to generate the force. Okay, so you can just go through this one. Okay, and for this, we go to the next one is AC motor. So AC motor, you can divide it into two parts, which is induction motor and synchronous motor. So this one is a task for you guys. So go to the YouTube video, go to it, and then go to the slide. Okay, I will share here. Then based on slide number 55, 55 of your discussion, what are the difference between induction motor versus synchronous motor? So this one you need to answer in the feedback form included. Okay, so in terms of the rotor construction, what's the difference? Okay. In terms of the stator contraction, what is the difference? In terms of the operating principle, what is the difference? So what application is normally used for induction motor and what application is normally used for synchronous motor? So we have one, just go through very fast and you need to submit it in the feedback form later on. And then for the motor selection, okay, when selection a motor for particular application, the factor that needs to be considered will be the initial matching, torque requirement, and power requirement. Okay, so let's look at the initial matching. So for example, is that you're going to you need to transfer the maximum power, and so the moment initial of the load should be similar to the load of motor. So if you were to have a motor over here, and you have the load, okay, so if the load is actually higher than the motor capacity, is that you can actually means that the motor capacity is lower than the load is too heavy, so you can actually rotate it. That's why sometimes you actually give to increase the motor, okay, motor torque or speed, you need to add a gearing system over here. So it's similar to how you apply a gearing system to your bicycle. Okay, bicycle. You are the one who are actually giving force to the bicycle. You are going to pedal, but if you do not have a gear, normally we typically call the bicycle without gear is the wheelie. Wheelie tak ada gear kan? Tak ada gear. Dia memang kena pedal very fast. But in compared to nowadays, we have the road bike and mountain bike. Mountain bike we have up to 7 gears, 12 gears. So 12 gears. So when you have these 12 gears, means that you actually transfer the load, the motor torque to the loads very easily. So you are going to pedal very easily, even though you're going uphill. So this is where gearing system is important, initial matching. And next is the total power requirement. Okay, is the sum of power required to overcome friction that need to oscillate the load. So as you know, okay, motor run in the capacity of is going to apply the to actually rotate. And normally, when you have a shaft right now, like this, you need to have a bearing to actually make sure that it's going to move in that direction and it's not going to move in this direction or go up and down. So you need to have a bearing to make it stay put. So it's going to actually rotate like this. So when you have bearing, you have friction. Okay, so you have friction. So friction is actually so power is the product of torque and angular speed. So power can be calculated using this equation is torque times the plus the angular speed. So you have torque times the angular speed plus the friction, actually plus the friction over here. So you have the moment of inertia of the load. So you have IL and you have the moment of inertia over here. Okay, so P can be actually calculated using this equation. Okay, do not worry about this. This one is just a general overview on how to calculate power, but in your exam, it's not going to be asked. It's more on the similar like assignment. But anyway, you need to know that when you have a motor selection, you need to make sure that the power is enough for the load that you are going to apply. Okay, so application of motor, just go through this video. Okay, I share a bit on where to apply this type of motor. For example, we have a brushless motor plus a gearbox system. And another one is that you have I think it's a DC servo motor. A DC servo motor plus a ball screw only screw for linear motion. Means that for DC servo motor, it's actually a rotary motion, kan? But you're going to actually transfer it to a linear motion. So how do you actually apply it, or how you actually assemble it? Okay, so that will be all for chapter 7. Okay, so before I go to this one, just a bit in 9:43, I have time. So make sure that you click on your attendance. Semua dah klik? 18 je baru, 18 je. So 18. How many students inside? We have 34 students. Right now I have 34 students inside. So how about the other students? 18 ni? 18 means berapa orang? Half of the student didn't do the attendance. Okay, make sure that you do the attendance. Make sure you do the attendance. Okay, remember guys, okay, guys and girls, okay, if you learn the asset up is very straightforward, you have the instruction, minority attendance. Make sure you minority attendance lah before 8. We start class at 8:30 kan, 8 dah boleh click lah. Okay, don't waste time to wait until after class. Do click it now, and then you have the class activity, and then you have the reflection. So this is the reflection that you need to do, Okay, reflection. Okay, like I said, reflection of the class for today is that you need to answer to the question in slide number 35. So this one, based on task in slide 35, in your own word, explain the 5 main difference between induction motor and synchronous motor. So I'm giving you not much time. I've given you until 1 p.m. 1 p.m. because last time when I give you 1 week, still student didn't submit. Okay, so right now it's until 1 p.m. saja to actually complete it. So make sure that you complete the feedback form by 1 p.m. Okay, attendance pun please take. And remember, guys, okay, for the assignment turning in, okay, this one is a turning in. Actually, when students submit, I can see how many students submitted. So I assume that these students submitted, they have completed everything. Okay, but they didn't upload yet. So I think for my student class, only 2 student Lau dengan phone 2 saja. The rest kosong. Tak siap lagi. Hopefully is still is on top of the assignment right now. You're doing your assignment, don't take too long. Okay, at least first draft should be coming up soon. Okay, week 13. Okay, week 13 I have uploaded the notes also. Okay, everything is on the control. So go through the slide. Make sure the tips, remember the tips I gave you in the beginning of this class is that pre-read the slide. Okay, pre-read the slide. Pre-read, go through the slide, get an idea what you're going to learn. Okay. So and then week 14, okay, week 14 is you're going to, okay, week 14, remember I have nouns in Telegram. You're going to have an online industry seminar. Actually for this subject, we have an industrial visit sebenarnya. Industrial visit means that you're going to go to visit the company lah, but due to COVID, you cannot do that. So instead of that, we have the online industry seminar. So it will be on 20 January at 2:30 p.m. Roughly about 1.5 hours, 2:30 p.m. This one is compulsory for all students for section 1 and 2. Okay, make sure that you go through, and I will update the link later on in 14. And on Thursday, okay, I'm going to have the final class with you guys, revision on topic chapter 1 to 8. Basically, the revision is up to you guys. Okay, you want to ask question, you can ask question. I'm open to you at that time, 2 hours to ask question regarding class. Okay, and I will also comment on the weekly class even and invite give you assignment submission. Means that I'm not going to go through everything, but I'm going to select the best answer given by student, and I'm going to share to all, so that you can see this one is the best, and this one means that the best, and you get full marks if you do this similar in your final exam. And of course, the one that not selected is not going to get full mark. Okay? So I have uploaded that. Alright, so any question? Any question, guys?
No.
No question, doctor.
No question. Betul tak ada question? Any question about assignment then? Because I saw that a few students, not banyak lah, dalam 3 students saja contacted me regarding assignment, just to ask to confirm about the assignment task. So if you want to ask more on assignment, you can do that. You can email me and ask, Doctor, I want to get clarification and do this. I'm okay. You need to ask, okay? If not, you can ask during assignment, but not during final exam. Final exam, you can ask question. Okay, you need to understand the question. But for assignment, you still can ask the question. And a tip for all students, even though for assignment, you're given one case study to answer. Okay, make sure that I would suggest that I would suggest that you go through the other case study. Means that if your case study is case study number 6, as you know, we have total 15 case study. So you go through, look at other example of the case study. Case study 1, oh, this is the question. So how should I answer if this is the case study? Get the problem. So you go through the other case study. So that is how you should study for your final exam. Don't just refer to your own assignment. And I'm not going to compile everything and give you the answer or solution. That is not how university work. This is not high school. I give you all the schema jawapan. No, that's not it. In university, you need to be more creative. Creative means that you have lots of students. Okay? You have students, you have friends that doing the same assignment but haven't different case study. So what you should do? Be creative. I'm not going to give you answer on how to be creative, because that is what you should be able to do right now. Be creative. Exchange with your friends or this one, but maybe you can improve your friends' answer and so on. So that's why having a group or clique is important. If you don't have group or group members, of friends to discuss. So that I wouldn't say that's a disadvantage. Yeah. Last time when I was during my study during university, I didn't have any group, no group. I was alone. People call me Lone Ranger. Lone Ranger. I can just adapt to any of my friends, join any friends, Chinese student, Malay student, Indian student. I just click with everyone. So by doing that, you are more robust actually. Okay? You are not going to actually be dependent on anyone, but you're depending on yourself to actually find the solution. Okay? So, and in the end, people actually my friends actually refer me as the skema jawapan. Okay? So, hopefully there are some students like this. Okay? Be independent, because this is the character that industry look to when they look for students and as their workers. So they need to be independent, or call it confident of yourself. Okay, so no question, No question? No question? No one? Alright, if no question, then make sure that complete the feedback form before 1 p.m. and then make sure that the attendance is tick. Okay, that will be all. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Bye.
Thank you, Doctor.
Okay, bye.